All right, find the area of a rectangular room whose length is 12 times the square root of 6 feet. How many of you measure your room and say, oh yeah, this is 12 times the square root of 6? Yes, there's a hand in the back. Okay, 12 times the square root of 6 feet, and width is 20 times the square root of 3 feet. I might do that, just to annoy my kid. Okay, and we want the area of that room, so let's do that. All right, we know area is length times width. I might tell her, your allowance is the square root of 2 divided by 8. No. Okay, at any rate, A equals L times W, and let's just do it. Length is 12 times the square root of 6. Width is 20 times the square root of 3. We really have already been doing these because we knew just to check when we simplified, we kind of told you how to do this. But we're going to go more into it right now. You just multiply 12 times 20, multiply the coefficients. 12 times 20 is 240. Okay, and then multiply the insides, square root of 18. You're probably going, no, they don't match. They don't match. Well, they don't have to match. We're multiplying. The only thing that has to match is the index, and the index matches. So know what you need. Same thing. It's the same thing with variables. Look, when you have variables, you can multiply. X times y is xy. I can't add x plus y because they're not like terms, but I can multiply them. Okay, so same kind of thing. Now, I regress to here, but you think I'm done. I am not done. Tell me why am I not done? Do you know why we're not done? I'll tell you. You know why I have to tell you? Because you're not really at class. No, here we go. Here's why I have to tell you. Because the bottom line is that there is a perfect square in here. Let's think about that. The perfect square in 18 is 9. So we have the square root of 9 times the square root of 2. This is 240. The square root of 9 is 3. Times the square root of 2. 240 times 3 is 246, and another 120. 720, square root of 2, and its area, so it's square feet, okay? And you kind of have to go like that. 720 square feet. 720 square root of 2. So actually, you don't need the parentheses there because that's one term. You can have it if you want it, but you don't need it because it's attached by multiplication. So 720 square root of 2 times the square root of 2 square feet. That's how you multiply. Okay, so let's take a look at some one division problem right away. It's square root of 60 x to the 11th y to the 4th over the square root of 3x squared. Okay, now listen. Depending on your teacher, everybody will do this different. I'm going to tell you how I do it. This is by the way, this is the exact same question as this. I do not want you to be deceived by this. What I do, as long as the indices match, is I reduce. It's the first thing I do, unless I see this is a perfect square. This is not a perfect square. What rooms it from being a perfect square is that 3. That 3 is not a perfect square. You saw me do this before. There was like a square root of 4 there. I didn't reduce. I took out the square root of 4 and said 2. So if this is not a perfect square, I just reduce. So I'm going to reduce, and I'm going to get 3 into 3 goes once. 3 into 60 goes 20 times. X squared, good night. There's 9 left up here. So now what I really have is the square root of 20x to the 9th y to the 4th over the square root of 1. But the square root of 1 is 1, so I really don't need to write that. So what I have is, ready? The square root of 20 x to the 9th, y to the 4th, okay? Now I can simplify this. We know how to do this. Yes, perfect square, not a perfect square, not a perfect square. As soon as I say not a perfect square to any factor, I have to break it up. Okay, let's talk about the biggest perfect square in 20. Okay, let's write down some of our perfect squares. 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. So the biggest one is 4. It's 4 times 5. Now, do you remember what we do with the exponents? We take multiples of the index. So we're going to do 2, 4, 6, 8, 10. Hike. 2, 4, 6, 8, 10. The closest one without going over is x to the 8th, right? We want the closest one to 9 without going over. We have x to the 8th. But x to the 8th times x is x to the 9th. Y to the 4th is perfect. If he's perfect, don't mess with him. Kind of like a good date, you know? Okay, If he's perfect, don't mess with him. Well, whatever. All right, here we go. So we have to take the square root of 4x to the 8th y to the 4th. We have to make sure this times this is this. We have to make sure all our perfect squares are here, and nothing here can be simplified, and that's what we have. Take this out of the house. We have 2x to the 4th. Remember how to do that. 8 divided by 2 is 4. Y squared, square root of 5x. We are done with that problem. So when we multiply or divide, all we're going to do is we're going to multiply outsides with outsides, insides with insides. We're going to divide the same way. If we had coefficients here, we could have reduced them, but we're going to do outsides with outsides, insides with insides, and then take care of whatever is left. So I'd like you to go to your workbook, stop the video, try the next 4 problems, and then we'll come back and look at them. Did you see the little note on the bottom of the slide? It's in your workbook. It said, what do you notice? So I'm hoping you looked for something you noticed. Square root of 3 times square root of 3 is square root of 9, but the square root of 9 is 3. Square root of 7 times square root of 7 is square root of 49, but the square root of 49 is 7. Okay. Square root of 2 squared. That's the square root of 2 times the square root of 2, which is the square root of 4, which is 2. Square root of 5 squared. Square root of 5 times square root of 5, which is square root of 25, which is 5. What do you notice? Actually here, we're squaring a square root, aren't we? We're squaring, because that's what we're doing, multiplying something by itself. Squaring a square root, we're getting what's inside. 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 Why? Because, think about this. If I have square root of 7 squared, okay, it doesn't matter if the square is there, actually, or there, okay, like that one's written. I can reduce the exponent by the index, and we just get the 7 back, because that means we're going to have 2 factors of that. I'm going to have 2 factors of that, and that's what the definition of square rooting is. 2 factors that equal that number. So when you square a square root, you get what's inside every single time. When you square a square root, you get what's inside. So if I have square root of, let's do this, square root of your mama, squared, what do you get? You get your mama. That's what you get. Because when you square a square root, you get what's inside. Important. Okay, so maybe that'll be helpful to you, maybe not. Whatever, the next 6 problems, you're on your own, and then we'll come back and we'll look at it. So stop the video, try these next 6 questions, and then we'll do them together. All right, let's kind of just put everything together what we've gone through. Square root of 10 times square root of 5, same index, we can multiply. We get square root of 50. But square root of 50 is not a perfect square. We're done if we can't simplify it, but if we can, we have to. So let's look over here and see that there is a biggest perfect square in 50. There is a perfect square in 50. It's 25. So let's, and that, I think that came up now 4 times. Square root of 25 times square root of 2. And we get 5 square root of 2. We are done. Okay, here we go. Outside's 18, but square root of 2 times square root of 2 is 2. We just saw that. Ha, right? When you square a square root, when you multiply a square root by itself, you get what's inside. If you can't see it, watch this. I'll do it the long way. The long way is okay. 18, and it's still times, everything's times, square root of 4. But square root of 4 is 2, and we get 36. So there you go. But had you realized that square a square root, you get what's inside, we would have had that. You put that to music. Square a square root, you get what's inside. Cube a cube root, you get what's inside. Yeah. Okay. All right, here we go. We're going to multiply outsides with outsides. The coefficient of this is a 1 that you don't see. So that's not the index. That's the coefficient. So the index is 2. Okay. So the coefficient is a 1. 8 times 1 is 8. Square root of 30x to the 5th. Okay, see what we can do with this. We know we're not done here because of that 5. That 5 is bigger than 2. We know we're not done. So we may be able to deal with the number. We may not. So let's go. We're going to break this up into 2. Okay, 30. 25 times nothing, 16 times nothing, 9 times nothing, 4 times nothing. Cannot break 30 up. 30's a loser. Ain't perfect. Okay, x to the 5th. Okay, we're going to take multiples of 2. We're going to take multiples of 2. 2, 4, 6. Closest one without going over is x to the 4th. X to the 4th times x. And now you have 8 times square root of x to the 4th is x squared, square root of 30x. That was fun. How was that for you? That was good for me. Okay, those are 3. We have 3 more to do, and then you can try some. Okay, let's take a look at this. If you feel like you know what this is, we can even do this power to power, right? We can do 3 squared, square root of 8 squared, okay? Square root of x squared, if that makes you happy. If that's a little too tough, we can do this. We can just write it twice. And we get 9. We know the square root of x times square root of x should be x, right? Because square or square root. Because that's x times x, x squared, which is just 9x. You're done. But if you know some little shortcuts, great. If you don't, and you don't know when to use it, don't do it. Just do it the long way. It's fine. Okay? I'm going to reduce here first, because I can. I have the pen. Okay. 6 goes into 6 once. 6 goes into 24 4 times. That's the square root of 4 over 1. The square root of 4 over 1 is just the square root of 4, because the square root of 1 is 1. So it's the square root of 4. Square root of 4 is 2. Done. Okay, let's take a look at this. We're going to reduce. 15 goes into 15 once. 15 goes into 128 times. Okay? On the bottom, good night, and there are 3 left on the top. So I have the square root of 8x cubed over 1, which is just the square root of 8x cubed. Now, definitely I have to break that up because this is bigger than this. Let's see what I have to do with the number. Square root. 4 is the biggest perfect square in 8. 4 times 2. X squared, take multiples of 2. X squared is the closest one, times x. Notice, this times this will give me this. Square root of 4x squared is 2x. Square root of 2x. We are done. Okay, now you have 6 to play with yourself. Please stop the video and make sure you try them, and then we'll come back and we'll look at them together. Okay, these are on you. Let's see what you got. 3 times 27 is the square root of 81. The square root of 81 is 9. You're done. Beautiful. Coefficients with coefficients, as long as the index matches, we're good. 2 times 3 is 6. Square root of 40. You can't say you're done unless we're sure that there's no perfect square factor in here, so we have to look. Okay? Perfect squares, 36, no. 25, no. 16, no. 9, no. 4, yes. 9 times nothing gives me 40. 16 times nothing. That's what we're doing, times, remember. That's why 4 is where we go. It's got to be a factor. Okay? So 4 times 10. Here's why else I know I'm correct, because 10 cannot be broken down. Okay? So we have 6 times the square root of 4 is 2, square root of 10. 6 times 2 is 12. 12, square root of 10. We're a done deal there. Okay? This one? Let's take a look. 2 is the only number outside. Square root of 10x to the 5th. Notice we already said 10 cannot be broken down, but we have to work on x to the 5th because that exponent is bigger than the index. We have to keep going. Here we go. I hope you kept going. 10 can't be broken down. Now we have to take multiples of 2. X to the 4th is the closest one without going over, because remember it's got to be even, times x. So now we have 2. Square root of x to the 4th is x squared. Square root of 10x. Done. Awesome. Okay, so we have 3 left that we're going to go over. Okay, so we'll take a look at that in a second. Okay, you feel good about these? Would you give me money? Can I bet you on these? No, huh? All right, here we go. We can write this twice. You can do power to power. You might feel better about writing this twice until you get more familiar with what's really going on here. Okay, 10 times 10 is 100. Square root of 3y times square root of 3y should be 3y, right? When you square a square root, you get what's inside, but I will do it the long way. 3 times 3 is 9y squared. Guess what that is? 3y. All right, so it's 100 times 3y, which is 300y. Done deal. Feeling good? Good marker. All right, we can reduce. 3 goes into 3 once. 3 goes into 51 17 times. That's the square root of 17 over the square root of 1. The square root of 1 is 1. So that's all I have. I'm done. Wasn't that pretty? That was nice. Okay, I'm going to reduce here. You ready to reduce? Okay. How many times does 50 go into 600? Yes, that's 12 times. Okay, good night. And we have 7 left here. So we have the square root of 12x to the 7th, square root of 12x to the 7th divided by the square root of 1. The square root of 1 is 1, so I don't need to write it because it's just 1. This divided by 1. Okay, we definitely know we need to split this up because that exponent is bigger than the index. So here we go. And we'll talk about the number in a minute. Okay, 12. The biggest perfect square that divides into 12. 9 times nothing, but 4 times 3. So it's 4 times 3. Yes, what do we have to do with the exponent? We have to do the multiples of the index. So 2, 4, 6, 8. Okay, the closest one without going over is x to the 6th times x. Again, multiply these together, you'll get this. This is a perfect square because it's even. This is a perfect square because it's 4. 2 times 2. So here we go. Square root of 4 is 2. X to the 3rd, divide by 2. Square root of 3x, and we're a done deal. I love those. I love those. Okay, let's take a look at the next 3. Because I think the next 3 are something that you've seen before that you really can say, well, I can do this because I've done something quite like it before. So I'm going to get those on the board, and then we'll get started. All right, let's take a look at this. Now watch. I have one thing out here, okay, and I have 2 terms out here. Isn't this almost exactly like this? It's no different. I have multiplication over terms. I'm going to distribute this. But remember, when we multiply radicals, we have to do insides with insides and outsides with outsides. So we're going to do that, okay? It's very, very simple. So it's just the distributive property. Here we go. Okay, I found my green marker. I'm very excited. Okay, insides with insides. Square root of 2x times the square root of 7 is the square root of 14x. A positive times a negative is a negative. Square root of 2x times square root of 3x is square root of 6x squared. I almost got away with doing nothing. Okay, let's talk about if we can combine here. Okay, we cannot combine because even though the index matches, the radicand does not. Okay, everything inside has to match, and it does not. That's not thick enough for me. Makes me crazy. Okay, 14. Let's see if we can break this up. 14. No perfect square in 14, so I can't break 14 up. I can't break x up because it's less than the index, so that has to stay just the way it is. 14x minus. Okay, we know we have to break this up because the exponent is not less than the index. So we're going to break this up. 6 we cannot break up. 9 times nothing, 4 times nothing gives me 6. So 6 stays here. X squared is perfect. It comes there. So I now have the square root of 14x minus x times the square root of 6. And that's it. I am done. Okay? Pretty cool? Know when you're done, know when you're not done. That's important. Okay? And these big numbers can't always be broken up because it's based on these perfect squares. Okay, let's look at number 2. 2 is a lot like this. And what would you do there? You'd FOIL or distribute, 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 distribute. You should have a binomial times a binomial. So we're just going to distribute here. Ready? Here we go. So we have seen these before. All right, just not exactly like this. There's a 1 here you can't see. 7 times 1 is 7. Square root of 3 times square root of 3 is square root of 9. Okay? A positive times a negative is a negative. Look, this is an outside number. 5 times 7 is 35 square root of 3. Now coming this way. Positive 1 times 1 square root of 3 is positive 1 square root of 3. Okay, I'm breaking into my other thing here. It's okay. Last one. Positive times a negative is a negative 5. That's what we got. So we have, watch this. This is 7 times 3, because square root of 9 is 3. These are like terms. I owe you 35, but I have 1 square root of 3 So I owe you 34 square root of 3's minus 5. I don't think I'm done. Watch what's going on here. 21 minus 34 square root of 3 minus 5. Now we have numbers. We can combine them. 16 minus 34 square root of 3. Cannot combine them. That does not have a square root of 3. I'm finally done there. Pretty cool? All right. Very last one. The square root of y. Remember, no power to power on terms. No power to power on terms. We're going to have to write it twice. And guess what? Binomial times binomial, I'm going to have to distribute this. Square root of y times square root of y is the square root of y squared. Or if you remember the rule, if I square a square root, I get what's inside, so that should be y. Positive times a positive, positive. 2 is on the outside, square root of y is on the inside. Same thing here. Plus 2 square root of y plus 4. So I have square root of y plus 4 square root of y plus 4, and I am done. How awesome is that? So you have seen all of these before. Now it's your turn. So try these next 3, and we'll call it a lesson. All right, let's take a look at this. I'm going to distribute. This is just like before. Square root of 6, okay? And this is a positive times a negative, which is a negative 7 square root of 18. Are you done? Well, let's talk about that if we're done or not. Okay, square root of 6, we know 6 cannot be simplified, but 18 can. Square root of 9 times square root of 2. So here we go. Square root of 6 minus 7, this is times 3, square root of 2, square root of 6 minus 21, square root of 2, cannot be simplified because I do not have like radicals. So I'm done. I hope that went okay. And I'm telling you, I think the perfect square list is really, really helpful. And I will, right after this slide, tell you what I would probably do to help you with that. Okay, let's take a look at this. Foiling or distribute, 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 distribute. 9 times 2 is 18, square root of 35. That's a positive 9 square root of 5 minus 16 square root of 7 minus 8. Oh, I cannot combine anything here because no like terms. But is there any perfect squares? Well, there's no perfect squares, but there's any perfect square factors. Let's see. 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. No, there's not one of those numbers that I can break down. We are done, even though that is ugly. We are done, okay? So that's it for that problem. 18 square root of 35 plus 9 square root of 5 minus 16 square root of 7 minus 8. It's a done deal. Look, I gave you the easy one. Okay. No power to power on terms, so I have to write this twice. Okay, ready? Outsides with outsides. 9 square root of x squared plus 10 times that outside 3 is 30 square root of x. Same thing here. Plus 30 square root of x plus, I'm going to put that here, plus 100. 10 times 10. These are like radicals. This is 9x plus 60 square root of x plus 100. I am done because there's no like terms. So that's it. That takes care of that. Okay, before we finish, I just want to give you, I think that list of perfect squares and perfect cubes are helpful. So if you just set up your paper, a piece of loose leaf like this, root 1, 2, 3, 4, 5, 6, 7, and you can go on. I'm going to go to 7. You can add on to this. I'm going to do perfect cube. Oh, perfect square first. I'm sorry. Perfect square. Perfect cube. And you go 1 times 1 is 1, times 1 is 1. 2 times 2 is 4, times 2 is 8. 3 times 3 is 9, times 3 is 27. 4 times 4 is 16, times 4 is 64. 5 times 5 is 25. 5 times 5 is 125. 6 times 6 is 36. Times 6 is 216, but who cares? That's kind of big. 7 times 7 is 49. That's probably as most you would need for cubes, but if you want to keep going, you can, and you can extend that list. That tells me these are your first 7 perfect squares. These are your first 1, 2, 3, 5 perfect cubes. And I know if I see an 8, I know it's a perfect cube. If I see a 9, I know it's a perfect square. The square root of 9 is 3. The cube root of 64 is 4. It's kind of nice, makes it easy, and you have a list for yourself. Okay? That takes us to the end of lesson 4. One more lesson in this mod, lesson 5.